Today we are learning about aromatic, anti-aromatic and non-aromatic compounds, that how can we distinguish between them. Well, first of all, look at aromatic compound, that these aromatic compounds should be cyclic. First and most important condition is that they should be cyclic. Like here I draw a non-cyclic compound, whether there is single and double bond or in conjugation, these cannot be aromatic at all. Second most important condition is that these compounds should be planar. If we talk about at hybridization, like these compounds should have sp2 or sp hybridization in them. Like for example, if we talk about sp3 hybridization, like here you can see that two bonds are in the same plane. Third plane is above the plane and other is below the plane. Above the plane mean toward us, below the plane mean away from us. So these bonds are not in a single plane. So we do not consider these sp3 hybridized compound in aromatic. So aromatic compound should have sp or sp hybridization where all the bonds are in single plane. Third condition is they should be in conjugation, means they have a single and double bond, alternate single and double bonds. Fourth most important is that they should follow Huckel rule 4n plus 2 pi. And here n can be 1, 2, 3 or anything. Like here you can see that if I put 0, 0 1 2 3, if I put 0 on n, then 4 into 0 plus 2, it will be equal to 2 pi electrons. Like here you can see that only 2 pi electrons are in this molecule and these are in conjugation, so it's an aromatic compound. If I put 1 on n, so it can be 4 into 1 plus 2 is equal to 6 pi electrons. Like the most famous example of aromatic compound is benzene. It's also aromatic because it follows Huckel rule. It is cyclic, it is planar, it has conjugated alternate single and double bonds. Third most example, if we look at, it has 2 pi electrons and one lone pair. Lone pair is also considered as double bond because it can be in conjugation, like it should be shifted here and this double bond will be here, and in the same manner it can be in conjugation. So we consider that 1 2 3 4 5 6, so here also 6 pi electrons in this compound. If we look at the other example of heterocyclic compound, it's a pyrrole. If we look at 4 pi electrons here and 2 lone pairs on nitrogen atom, which is also in the same plane with the molecule, so it's in conjugation with the molecule. So we also consider pyrrole as an aromatic compound. If we look at anti-aromatic compounds, like you can see that these compounds are cyclic. Here they are also planar, they are conjugated like aromatic compounds, but here they follow 4 pi electrons, not Huckel rule 4n plus 2 pi electrons here in the case which is in aromatic compounds. So if we look at the example of cyclo 1,3-butadiene, like you can see it's a cyclic, conjugated, planar, but it has only 4 pi electrons in its molecule, so it's not aromatic. It is considered as anti-aromatic because it follow all the conditions of anti-aromatic compound. If we look at the second example of cyclopropene anion, like I already mentioned that these negative electrons are also considered as a double bond because these are in conjugation between the molecule. So if we calculate 1 2 for double bond and 1 2 for anion charge, so there should be 4 pi electrons in this molecule also. If we look at here also 4 pi electrons, so it's not aromatic, it's anti-aromatic. If we look at this molecule, here there are 3 double bonds and 2 lone pairs, 2 lone pair on oxygen atom. You know that these 2 lone pairs are in perpendicular condition to each other. Only one of these lone pair is in the molecule and it's aromatic. So if we calculate these pi electrons, so here are 1 2 3 4 5 6 7 8, so it's not do not follow 4n plus 2 pi electrons. It is also considered as anti-aromatic. If we look at non-aromatic conditions, these molecules are also cyclic, but they have disturbed conjugation due to non-planarity. These are non-planar. They may follow Huckel rule or not, but due to disturbed conjugation, they are considered as non-aromatic. You should remember that these compounds are also cyclic. Those non-cyclic compounds are also not considered as non-aromatic. So non-aromatic compounds are also cyclic. If we look at the examples of these, like if you look at this molecule, you may consider as anti-aromatic because it is cyclic. It is looking as planar, conjugated, and it follows 4 pi electron rule, but it is not the case in actual. This molecule actually is in a cup shaped condition. So here you can see that this molecule is non-planar. Whether it is conjugated, it is cyclic, but it is non-planar, so these molecules are not in continuous conjugation with each other, so this molecule is considered as non-aromatic. If we look at other molecule, like here you can see that there are those number of electrons which follow Huckel rule. It is cyclic, but it is not considered as aromatic due to non-planarity. These two hydrogen bonds are making it non-steric, so there is no continuous conjugation here in this molecule. If we ask me whether this molecule can be changed to aromatic, so yes, I can say that there are two methods of this to change it to aromatic. One is cyclization. If you remove these two hydrogen molecules and cyclization somehow occur, then this molecule is converted into aromatic compound, which is naphthalene. Second most condition is if you change it to uh, by somehow a metal atom is added to it, and it is also changed to aromatic compound by somehow, but in this condition this molecule is non-aromatic. So these are the main differences between these molecule. If we look at the stability order of this molecule, like you know that aromatic compound have the most resonating energy, so these are the most stabilized molecule. Secondly, non-aromatic molecules have greater stability than anti-aromatic. Anti-aromatic compound have very much less stability. Either these can be separated at very low temperature due to double bond in conjugation. These molecule can be separated by Diels Alder reaction, whether they are considered as diene, work as also dienophile, but at normal temperature, at higher temperature, these are present in these are not separated from their molecules, but these are present in a dimerized form of these molecules.